Imagine I have an analog signal in black, alright, in this one. It's a continuous system. Alright, and I have a certain restricted sampling frequency. Right, I'm restricted. Alright. Therefore, if I were to sample this analog system right now, I may have something like this. Okay? So, if I were to use a controller, which is what we have been discussing all along for digital to analog system DAC, alright, do I make sure that my output analog signal is exactly the same as this black one? Alright, as we straight away know that the first step, one way is to increase the frequency. Right? If we increase the intake frequency, meaning in the purple color now, then I can better represent my black signal over here. Right? Better, right? But however, because of restriction, as I said earlier, what can we do about it? And this is where we're gonna talk about the Euler's formula again. Alright, and in this time we talk about the PID approach. Still go back to this for example this stuff over here. Okay, instead of actually changing the frequency, the intake frequency, we have so many values that represents. For example, this, if you take a look, this thing over here is C1, for example. This thing over here is C2. This thing over here is C3, for example. Okay, we have so many variables within here to actually change our parameters. Alright, so I'll just briefly, I'll not detailedly say because I don't know how to do, but just that you have all this value k, you have all this t and things like that. Alright, so when we have all this, we can simply just change the values of them. Alright, I think this is also a period, so this period will link to the frequency, but never mind. If let's say this are something that we can't change, or the frequency that we can't change, we can also change the k values in this case. Alright, and other input parameters that would change our path to better represent our signal better. Alright, and this is just a short awareness on this understanding that we can change the in-between values, or in other words, if you were to go all the way down to over here, right, you can change the 1 minus bt, if you remember, is s plus a over s plus b k. We can change a and b value, we can change k value, we can change all this value such that your signal will be better represented rather than changing the frequency itself. Alright, and this is it for this, and bye bye.